Hey everybody, today we're going to take a close look at completing the square and how it leads us into the quadratic formula. Okay, to make a perfect square quadratic trinomial. We've done this with the Harvard Square It. But let's take a look at perfect square trinomials because they really do geometrically create squares. I'm going to take a look at first, we're going to look at f of x is x plus 4 squared. So we did this down here, x plus 4 times x plus. And when we get it, we have x squared, 4x, 4x, and 16. Notice that each side is the same length. We've actually created a square. And we know how to do perfect squares already. We have it square things. For instance, down here, I would take 12, the linear coefficient, halve it, and square it. Of course, 12 over 2 is 6. 6 squared is 36. So 36 would go in the box to make a perfect square. Let's get rid of all of that. Take a look at the second one. Minus 8, half of that, half it is negative 4, and then square that to get 16. So we know how to create perfect squares, and they actually create a square. Now let's make a perfect square with just x squared plus bx. What would go in the box? Well, we're going to take our linear coefficient b, we're going to halve it, and then we're going to square it. So it becomes b over 2, and then in parentheses, squared. So this becomes b over 2 squared. So f of x is x squared plus bx plus b over 2 squared. That's a perfect square trinomial. And its factors are x plus b over 2 times x plus b over 2. Now this x plus b over 2 squared, and then this constant term at the end, b over 2 squared, why is that? Let's just take a quick look geometrically. I have x squared plus bx, and I'm wondering, what do I need to add to this to make a perfect square? So if I join them together, I get a rectangle, but I need to get a square. So let's make some clever rearranging. I'm going to take bx and snip it in half. And I'm going to take half of it and lay it up here and leave the other half right here. So this is b over 2 units wide, and so is that. Now I just need to fill in this little section up here. And what is its area? Well, one side is b over 2, and the other side is b over 2. It turns out the area I need to add is b over 2 squared. And that's why we have it squared. A couple more examples. F of x is x squared plus 6x minus 7. So we want to set that equal to 0 to solve it. Send 7 over to the other side. Create a perfect square. Make sure you add the same thing to each side. Factor it, and then solve. Notice that we get x is negative 7 and 1. But maybe on closer examination, we should have taken a harder look at this, because if you notice, x squared plus 6x minus 7 can be factored. That is equal to x plus 7 times x minus 1. And that would mean that if x plus 7 is 0, x would have to be negative 7. And if x minus 1 was 0, that means that x would have to be positive 1. And of course, that's exactly what we caught. It pays to look to make sure that see if you can factor. Here's one that we can't, although it looks tempting with a perfect square on each end. Negative 14, we'd have to halve it and square it and get 49. We have 16, so away we go. Let's complete the square. Send 16 over, minus 14, there's my 49. I'm going to add that to each side. This becomes x minus 7 squared, minus because of that 14 there, the negative 14. Minus 16 plus 49 is 33. Take the square root of each side, solve for x, and make a numerical approximation in case you need to plot this. Now here's one that looks a little scary, and here's where we're going to actually develop the quadratic formula. we are going to complete the square on ax squared plus bx plus c. We're going to solve it by completing the square. So I set it equal to 0. I notice that I need x squared. I have a there, so I divide it out, and there it is. B over a, c over a. I divide both sides by a. 0 over a is equal to 0 still, so the a disappears. I'm left with x squared plus b over ax plus c over a equals 0. Once again, take your constant term, send it over to the other side. Take your linear coefficient, halve it, and square it, and make sure you add it to each side. Now you've factored this perfect square trinomial you just created right here, and you've added b squared over 4a squared to each side. Notice that I have to add these two fractions. My common denominator is 4a squared, so I'm going to have to put in a 4a on both the numerator and denominator to get these two denominators to be the same. So here they're the same, and I combine them right here. All right, hang in there, we're almost done. We factor that, b squared minus 4ac over 4a squared, and take the square root of each side. Here's us taking the square root. Notice the square root of a over b is the square root of a over the square root of b, and the square root of 4a squared is 2a. So I get x plus b over 2a is b plus or minus the square root of b squared minus 4ac, all divided by 2a. Bring this over so we isolate x all by itself, minus b over 2a plus or minus, etc. And now we finally get the quadratic formula, and I'll change colors here so we can emphasize it. Right in here is the quadratic formula. And that's how you got it. You don't necessarily remember, you have to remember how you got it. You want to remember that formula though. Okay, let's try one with the quadratic formula. We have x squared minus 14x plus 16. This should seem familiar, where a now is 1, b is negative 14, and c is 16. We're going to use the quadratic formula to solve this. I usually write down the quadratic formula at the beginning of each problem that I use it on. That way it stays in my head as to what it is, and you should remember that formula. So I take out minus b, I take out b and replace it with minus 14. I substitute in 4ac, etc., 2a down below. You can see my math going along here. Let me just change colors. There we go. And we get 14 plus or minus the square root of 132 over 2. I look at 132 and realize that 4 goes into it, so I pulled that out. I have 14 plus 2 times the square root of 33 over 2. 14 over 2 is 7. 2 over 2 cancels out to just the square root of 33, and I end up with 7 plus or minus the square root of 33. And you saw this a couple of screens ago. Okay, that's it for today. Here's the thing to remember. Take care and be well.